Hi all, this is Mr. Yates here. I'm here trying for the first time to teach my Year 11 Methods class via a video instead of doing it in person. Now, as this is my first attempt, I may make a few mistakes, but we'll see how it goes, and if it goes well, we can expect to have more of these in the future. Now, this is for my Year 11 Methods class at Fremantle College, but if anyone else happens to tune in, that's fantastic, and I hope you get something from it. So for those who are part of my class, I have created a handout that you can download from the Connect page, but I'm just going to go onto the page itself. So there we have it. And we're starting with a typical exam question. Now, this exam question is very similar to the kind that you will get in your semester 1 exam later on this year. Hopefully that'll all still be going ahead in one form or another. But it's a pretty straightforward one. You'll see that it is worth 2 marks for the first part, 2 marks for the second part. This is a calculator free section. Now, when we've got calculator free, that also means you will not have any of your own notes. So usually with a lot of calculator free stuff, it's stuff you're expected to intuitively know, it's stuff you're supposed to have a bit of an understanding of and be able to answer pretty quickly without thinking too hard about it. So let's have a look at the question. Now, for the graph with equation y equals brackets x plus 1, close brackets, open brackets, x minus 3, close brackets, we want to find the coordinates, and that's an important term as well. I'm going to highlight that too. The coordinates of all axes intercepts. So what does that mean? Well, I'm just going to do a quick little sketch of what the graph itself may look like. So this is a parabola or a quadratic. And what we expect it to do, now this is just a guess from just looking at what we've got here, but I'm expecting a parabola that maybe looks a little bit like that. So that's roughly what we expect the parabola to look like. Now my intuition may be incorrect, it may be correct, but we'll see in a bit whether that ends up being the right thing. And we want to look at all axes intercepts. If we're looking at all axes intercepts, that means we are looking at this spot, and this spot. Obviously, these are the x-intercepts on, just a sec, there we are, x-intercepts on that one, y-intercepts on the top one there, and the x-intercepts occur when when y is equal to 0, because we're not moving up and down anything on the y-axis. So when y is equal to 0, we've got our x-intercepts, and we've got our y-intercepts when x equals 0. So should be pretty straightforward to do this. We've done this similar ones to this in class before. So what we want to do is we want to set, to find the x-intercepts, we set y is equal to 0 in this equation. So I'm just going to write that. 0 equals x plus 1, x take 3. And we can use what's called the zero product law. Basically, if anything in either of these brackets is equal to 0, then the whole thing will multiply to 0, because 0 times 0, or anything times 0, is equal to 0. So this one, x plus 1 equals 0, shouldn't be too hard to work out that x should be negative 1. This one over here, x minus 3 equals 0, shouldn't be too hard to work out that x is equal to 3. And these ones are often really easy to work out just by looking at them. You won't need to do this much working out to get your 2 marks if you just listed these. But we're not asked to list what x and y are. We're asked to list the coordinates. Remember, we know that y equals 0. So we're going to list our coordinates, and that will be negative 1 and 0. And the other one will be 3 and 0. So when it asks you to list the coordinates, you do have to list the actual coordinates. You cannot just write x equals negative 1 and x equals 3 because they may not give you full marks. Depends on the teacher, depends on the person marking, but they may not end up giving you full marks for it. So let's have a look at the other one. The other one occurs when x equals 0. So if x equals 0, we have y equals 0 plus 1, 0, take 3, which is just 1 times negative 3, which is negative 3, straightforwardly. Again, we want our coordinates, not our just our y equals negative 3. Remember that now x is equal to 0 for the first number is 0, and so that'll be 0 and negative 3. I always like to do a bit of a what I like to call a sanity check after doing any of these kinds of questions, and that's why I drew this sketch first up. Is my first x-intercept, does it look like it's on the left side of what we've got there? Yep, that looks reasonable. Does my other one look like it's in about the right spot? And does my y-intercept look like it's in the right spot? Now, I just sort of guessed this one. Well, I knew what it was going to be based on looking at the equation first off. But we can always do a sanity check and think, does this sound reasonable? Because we don't want to just throw maths at the wall and see what sticks. We want to actually know what we're doing with it. So we always do our sanity checks afterwards. Now, next one is the turning point. We're wanting to find the turning point. So I've got my 3 points. These seem about right. And our turning point looks like it's going to be there. So we need to sort of have a bit of an idea, where's it going to be? Now, all of our parabolas are always perfectly symmetrical, which means that the turning point is going to be exactly halfway between these 2 points. We know what those points are. They are at x equals negative 1 and 3. So if we find the average by adding them together and dividing by 2, we will get 2 over 2, which means that we've got 1, which will be the x coordinate of our turning point. Now, when we know the x coordinate, we have an equation, so we can just plug that straight into the equation. Oh, and I've got a little visitor. This is Smeagol. He's my boy who keeps me company when I'm doing pretty much anything around the house, and he can be a big pest. If the camera shakes for some reason, that's because he's jumped on the table when he's not supposed to. Anyway, boy, you're going to have to get off. It's a bit hard for me to do this with you there. So, we've got our x-coordinate there, and so what we've got here is we just want to plug that in. So that's going to be 1 plus 1, 1 take 3, which is going to be 2 times negative 2. By the way, that is y equals that. So our y coordinate is going to be negative 4. So our turning point, or TP, as I like to write it, is going to be, our x coordinate was 1, and our y coordinate was negative 4. Again, let's do a sanity check. Does that look about right? Yep, it's gone across by 1. It is lower than our y-intercept, which was at negative 3. So I can say with a good degree of confidence that I've done the right thing here. Now, this is only worth 4 marks of the exam, so it shouldn't be too tough a one to get out. And in fact, I could have just looked at that and seen, yep, x-coordinate is negative 1 and 3 just by looking at the at what we've got in there straightforwardly. And then I could just go, yeah, if x equals 0, y is going to be negative 3. That's pretty straightforward. You can do all of these ones probably in under a minute if you know what you're doing. The way that the exam is designed is so that you do approximately 1 mark a minute, but there will be some questions that are easier that you can do much more quickly than the allocated time. And these kinds of questions are the kinds where you save up time, you bank time so that you can do the harder ones and spend a bit more time on the harder ones. But always look in the exam for these easier questions because it'll really help you out to make sure you're getting 100% on those. Okay, so that's our exam question. Today we're looking at the idea of polynomials. We've touched on them before. I have mentioned that a linear equation and a quadratic equation are both polynomials. But polynomial functions have the following form, and this looks like a big complicated equation. When we look at it here, we've got an x to the n, an minus 1, x to the n minus 1, and so on. This is more confusing, or looks more confusing than it needs to. Basically, we've got some number, some coefficient of x to the power of whatever, and then we've got the next coefficient of the next power of x down. So this is our highest power of x, our next highest power of x. They're going to be multiplied each time by some number until we get to our final constant, and they're all just different powers until we get to our final one. Now, any of these values for a can be 0 as well. So below, I've got an example of a polynomial. We've got 3x to the power of 5 plus 2x to the power of 4, take x to the power of 3, plus x, and I'm just highlighting these, you'll see in a moment, and then take 17. So in each of these situations, the 3 here is our highest numbered coefficient. This 2 is our second highest numbered coefficient. Now we've actually got, you should always remember that when you've got something like that, you've actually got a hidden coefficient of -1 when you've got to subtract there, and a hidden coefficient of 1 when, and that's for this example, and a hidden coefficient of 1 for when we've just got plus x. And then we've got our constant at the end. Now, it's also possible for any of these numbers to be equal to 0. So you will have noticed that this one here doesn't actually have an x squared term. And because it doesn't have an x squared term, or the reason that it doesn't have an x squared term is because the coefficient of the x squared term is 0, and that eliminates that as one of the terms that are in the final polynomial. So I've got that highlighted down there. The x squared component has a coefficient of 0. So the highest power with a non-zero coefficient is called the order of the polynomial. So this is our highest power, 5 of this one. So this one has an order of 5. Okay, so that one has an order of 5. Our linear functions of the form y equals mx plus c. Let's get that out of the way for the moment. So our linear equations y equals mx plus c have an order of 1 because our 1 is our highest power. Quadratic functions y equals ax squared plus bx plus c have an order of 2 because their highest power is 2. So that's just something, that's just a bit of terminology that will help us out. We'll also be looking at, cubic functions. Cubic functions have an order of 3 and take the following form. So let's scroll down a little there. So they take the form of ax cubed plus bx squared plus cx plus d. So each of these coefficients are different. Some of them could be 0, but obviously a wouldn't be 0, or it wouldn't be a cubic function. They can also take this form, a x take p, x take q, x take r. And we should have learned from our exam questions, our exam question earlier, what exactly that means. So what will we know about a cubic taking this form? Take a minute to think about it. But what it means is that it will have 3 x-intercepts at P, Q, and R. So if I was to draw my cubic, it might end up looking like that. And you can try writing this and seeing what it looks like in your calculator, in your class pad. So you can just get a bit of an appreciation for what exactly is going on with that. So that's what we know about a cubic taking that form. So the most basic cubic is y equals x cubed, and it's graphed on the right here. Note that the y-axis is ramping up really quickly from 10 up to 70, so we're going, each interval is 10, whereas as we go left and right, we're only going up by 1, 2, 3, 4. If I was to graph that in here, y equals x to the power of 3. If I was to graph that in my calculator, put that in there, we can see that mine is much steeper than the one we've got over there because they've just changed the y-axis so that it covers a lot more values. Okay, so it's got a much higher range on the y-axis. So, cubic functions will not all be of the same shape, but they all have the following properties. They will either have 2 turning points or no turning points. So if it's got 2 turning points, that's because as we go to the left, it's going to point down. As we go to the right, it's going to point up. So if it turns around at one point, it's got to turn around again, so it ends up pointing up again as we go to the right. If it's got no turning points, that means it will have something called a point of inflection. And the point of inflection will be the exact point where it stops, and we can see that on this one, the point where it stops curving down and starts curving back up. And we've got a more sort of steep, it doesn't flatten out exactly, the point of inflection on this one, but we've got a point of inflection there all the same. They don't always go down on the left and up on the right. This one goes up on the left and down on the right. And the reason it does that is because our x cubed term is multiplied by a negative. So we've got a negative coefficient on that x cubed term. They will always cut the y-axis once because they are functions with a this is inconvenient. So they will always cut the y-axis once because they are functions that have a domain across the entire range of real numbers. And they will always cut the x-axis once because they've got to get through it somewhere. And they may cut the x-axis just once, or they may cut it twice, or they may cut it in 3 places like we've got there. So we can do the same sorts of things that we've already seen for our cubic, or for what we had in the exam question. So where does this cut the y-axis? We've got the equation y equals 2x cubed plus 3x squared plus 2x plus 14. This is much trickier than, this is much easier than it looks at first. It looks like it might be a tricky one because it's throwing all these numbers at us. But remember, the y-axis occurs when x equals 0. So no matter what it ends up looking like, at the point where this actually... What are you doing, Kat? You trying to get down? Or are you just having a look? Okay, let's get off. There we go. So, we know that it cuts the y-axis when x equals 0. So if x equals 0, all of these terms disappear. It's just 14. So the coordinates are going to be 0, 14. And the other ones just don't matter. So that is really easy. You should be able to work that out in a second if you know what you're doing. This one's similar. Where does this one? We've got this, the coordinates of the points where the graph cuts the x-axis. So it cuts the x-axis. Obviously, we've got our 0 index law again. So we need to find out where x equals, or x minus 1 equals 0. We need to find where 2x minus 3 equals 0. And we need to find where x plus 2 equals 0. So that's obviously x equals 1, x equals 1.5, or I'm going to write it as a fraction, 3 over 2, and x equals negative 2. Where does it cut the y-axis? Well, we set x to equal to 0, and if we do the y-axis, we do negative 1 times negative 3 times 2. Negative 1 times negative 3 is 3, times 2 is 6. So we're going to have our coordinates of 1, 0, 3 on 2, 0, and -2, 0. And this last one is going to be at 0, 6. Let's just sketch that, see if we can do that there. X minus 1, 2x minus 3, x plus 2 equals y. Doesn't matter which way around we do it. And I'm going to put that into my calculator here. And does it do all that? Yep, so we can zoom in a little bit. At -2, it passes through the x-axis. At 1, it passes through, and at 1.5, or 3 on 2. And if I scroll up, I can see that it intercepts the y-axis at 6 there. So I was able to do that. I was able to sketch it out. You should all get practice at sketching stuff out in your graphics calculator as well. Okay, so that's just a bit of a demonstration of how we can look at cubics. Now, we should have a look. Now, I've got the questions 1 to 8 from exercise 7A in the textbook. I'd encourage you to have a look at those. Yeah, so the answers are in the back of the book as well. You can have a look at those. And I may take 1 or 2 of the more complex ones of these to complete at the start of the next video. Anyway, I hope you've enjoyed this and have a great day. Bye.